Assalamualaikum. Hi, so today we are going to learn more about wave. We have learned that waves are carriers of energy, means they transfer energy from one location to another without transferring the matter of the medium. Now today we will look more about wave. There are many examples of wave. The microwave that heat our food, the radio wave that transmit pictures to our television set, and the sound wave that carry music to our ears are all examples of wave. These waves are divided into transverse and longitudinal wave. So we are going to look at the difference between longitudinal wave and transverse wave. We use a Slinky spring to produce transverse and longitudinal wave. When one end of the Slinky spring is fixed and the other end is moved from left to right or up and down. So for the first one, this is the spring Slinky. Okay. The blue dots represent a particle in the spring. So we will move the spring back and fro and forth to the right and to the left. So the spring move. So you notice that there is a compression and reflection region. And what is the direction of propagation of the wave? And what is the direction of vibration of the spring particles? So the wave propagates to the right and the spring particle vibrate back and forth. What can you say about the direction of vibration of the particle in relation to direction of propagation of the wave? So we have two. First, the wave of the spring Slinky move to the right, and the particle of the spring represented by the blue dot move either back and forth. So what can you say about their direction? So they are parallel to each other. Parallel means both have the same direction. A wave in which the direction of vibration of particle in the medium is parallel to the direction of propagation of the wave is called longitudinal wave. Okay. Next, we look at the second type of wave is transverse wave. The red dot represent a particle in the spring. So we will move this time up and down. So what is the direction of propagation of the wave? What is the direction of vibration of the spring particle? So the wave propagates to the right and the spring particles vibrate up and down. So what can you say about the direction of vibration of the particle in relation to direction of propagation of wave? So the wave move to the right. The red dot move up and down. They are perpendicular to each other. A wave in which the direction of vibration of particle in the medium is perpendicular to the direction of propagation of the wave is called transverse wave. Again, a wave in which the direction of the particle perpendicular to the direction of propagation of the wave is called transverse wave.
Hi guys, today I just want to show you a demonstration of transverse and longitudinal waves using a Slinky. Now, transverse waves, the direction of energy is going to be going forwards, and that's the same with longitudinal waves as well. The energy is going to go this way. But with a transverse wave, the medium, so in our case the Slinky, which is what the wave is going to travel through, is going to be moving perpendicular to the direction of energy transfer. So let me give this a go. So you can see the pulses or the waves are moving from the left to the right. So the energy is moving from the left to the right, but the actual slinky itself is moving perpendicular to the direction. Now another kind of wave is a longitudinal wave. Now with a longitudinal wave, the medium, again which is the slinky, moves in the same direction as the energy transfer. So the energy is moving in this direction, our wave is going to be, or the medium, the slinky, is also going to be moving in this direction. So this is a longitudinal wave, like sound is also a longitudinal wave. So in this case you can see that there's a part where the wave gets compressed and a part where the wave gets rarefied. And that these pulses move along in the same direction that the energy is flowing. So that's a longitudinal wave, like that. That's a transverse wave. Okay, bye for now.
Okay, as a conclusion, we have activity 3. To observe a longitudinal wave and a transverse wave using a slinky spring. So the first one, we move the spring back and forth. So this is the direction of propagation of the wave, okay? And this is the direction of vibration of the thread. So both have the same direction. So we say that they are parallel to each other. So this is what we call longitudinal wave. Direction of the spring wave is parallel to direction of the wave movement. And notice that also the wave travel has what we call a region of compression and refraction. This is the compression, this is refraction. And also we have the distance between the two successive refraction, or another compression to another compression is what we call wavelength. Okay. So for the second one, we have the transverse wave. So this time we move up and down, and the wave move to the right, and the ribbon move up and down. So the direction of the thread or the particles move up and down, and the wave move from left to right. So this is the direction of propagation of the wave. So they are both in perpendicular to each other. So this is what we call transverse wave. Okay, conclusion. A longitudinal wave is a wave in which the vibration of the medium is parallel to direction of the propagation of wave. Example, sound wave. Okay, another one, the second one, a transverse wave is a wave in which the vibration of particles in the medium is perpendicular to the direction of propagation of the wave. Example, water wave and electromagnetic waves such as light wave, radio wave, and microwave. Okay. So the analogy, we have a ulat bulu, a caterpillar, which move, it will compress and then it will move upward. So that is how it move. Another one, we have snake. Move like the snake, and this is the snake represent the movement of longitudinal transverse wave, and the caterpillar represent the movement of the longitudinal wave. Okay, that's it for today. Thank you. See you again.